Hopefully coming in here, polygons are fairly familiar, as we had with triangles in the last section, where there are a few very well-known patterns that we have for how a quadrilateral can present, where we call a quadrilateral a parallelogram if we have two parallel sides each, and in particular this means that opposite angles will also have the same measure. From there we call a parallelogram with all sides having the same length a rhombus, and a rectangle is a parallelogram, but not necessarily a rhombus, in which the angle measurements are all 90 degrees. From there, we get the combination in terms of a square, where we have all side lengths are the same, so it is a parallelogram, as they are also parallel, and all the angles are 90 degrees. These are probably the most familiar kinds of quadrilaterals. And then we have one other variety, the trapezoid, which is a quadrilateral with exactly one pair of parallel sides. And these aren't necessarily all of the quadrilaterals that can possibly be. There are other combinations, other arrangements we can have, but these are the main ones we'll see here, where for now we're going to get a quick application for how we can look at the perimeter of, in particular here, a rectangle. So suppose you want to enclose a rectangular field with side lengths 42 and 28 yards respectively. How much will this cost, assuming fencing is $15.75 per yard? So first off, a little bit unfortunately here, this textbook in terms of its examples tends to be set towards the financial aspirations and successes of a experienced math professor and not a poor math student, or for that matter, a less experienced math professor. So we're going to have to think a little bit hypothetically, think a little bit aspirationally maybe about some of these things we've got here. It's a little silly for our circumstances, but it's still a pretty straightforward example that what we have is an issue of trying to find the total perimeter, because we want to find out how much fencing it will take. We want to find out how to fit around the outside. That means we want the perimeter, where each foot, or in this case yard, of perimeter will correspond to $15.75. So if we want to get the perimeter P, hopefully remember the formula for the perimeter of a rectangle is 2 times the length plus 2 times the width, where we have that we'll call the length, in this case 28 yards, so we have 2 times 28 plus the width 2 times 42, which in this case would give a total perimeter of 140 yards. And that tells us if we want to find the total cost in fencing, that's going to be the perimeter, 140 yards, multiplied by the cost per yard of $15.75, for a total price of $2,205, which, yeah, it's a little silly to think for our purposes about spending $2,000 on a fence, but hopefully we'll all get there eventually. Anyway, this is one way we can talk about perimeters. So the next thing we're going to look at is how we can discuss the angle measurements of not just rectangles, not just quadrilaterals, but more general polygons.